Dementia comes in many different forms, which includes Alzheimer's disease, vascular dementia, and Lewy body dementia, each with unique symptoms and characteristics. It is globally prevalent. More than 55 million people worldwide live with dementia, with Alzheimer's making up most cases globally. Chances are we all know someone who will suffer from dementia at some point in their lives. It is critically important that we diagnose dementia early and that we increase awareness amongst people so that we can develop effective dementia treatments and manage that better and provide better support for families.
Hi, my name is Bob and I'm a data enthusiast.
Hi, I'm Carrie, and I've seen firsthand how dementia affects families. That's why this project matters to me.
My name is Ian. I love turning complex problems into smart solutions.
Hi, I'm Thomas. I'm here to push the limits of what SaaSwire can do.
We are the Dement AI team. We joined the SAS Hackathon to explore how data could help detect and prevent dementia earlier.
Our aim was to target Alzheimer's, and the way we wanted to do this was by firstly analysing and visualising health records, EEG and unstructured treatment data. We also wanted to build and deploy machine learning models to predict Alzheimer's based on that data. We wanted to score synthetic data against the machine learning model to infer signs of Alzheimer's, and then we wanted to create some agentic AI workflows combining the machine learning models, LLMs, and deterministic rules to help automate some of the different diagnoses and treatment phases. And finally, we wanted to provide governance and audit around all the artifacts used.
How did we approach our solution using SaaSwire? Analysed data, including EEG recordings and tabular medical data, has been accessed via cloud storage from SaaSwire. Python and SAS Visual Analytics have been used for data preparation, exploratory data analysis and visualizations once data has been loaded into the SaaSwire CAS engine. To build machine learning models, SAS Model Studio and Python have been used. Models have then been registered into SAS Model Manager. Finally, agentic AI workflows have been built in intelligent decisioning. Let's see how we have analyzed data from electroencephalography, which is brain waves recorded by electrodes on the patient's head. We import the standard libraries and also MNE, a Python package designated for such data. The data is stored in .set files, which we read into standard formats using built-in functions. We then uploaded the data to Vaya. Our visual analytics dashboard shows several line charts of each electrode of the EEG data over time, allowing comparisons between two or more research subjects, and uses a stacking container to swap between each electrode's plot. We created a similar page with several box plots to help understand the data distribution, especially between the different electrodes. We have created an animated heat map of the EEG electrodes data, transposing the data into a list of matrices, then plotting each individual matrix as a heat map, stringing them all together as a GIF file. An even better visualization is called a topo map, which averages out each EEG electrodes time series over a two-dimensional plane, creating a topological map of the brain. The brighter the color, the higher the intensity of waves. We decided on showing only 2.5 seconds of measurements. This helps show quite how much the brain activity changes over a very short period of time, allowing researchers and practitioners to pinpoint damaged areas. To predict Alzheimer's using the EEG measurements data, we have experimented with various models. In particular, recurrent neural networks are useful where the order of events matter. Using a cross-validation approach, our model reached an 85% accuracy score. This deep learning functionality is available in SaaSwire both using Python packages and CAS action sets. Here we show the quick technical scoring test results in a SAS dataset based on some synthetic EEG data. The model score of 0.815 means that for the test EEG recordings, the patient is showing the signs of Alzheimer's symptoms in brain activity. Using tabular health records, including demographic data, we have also built some predictions using SAS Model Studio. This tool gives the ability to automatically experiment many algorithms efficiently. Natural language processing pipelines have also been built to extract various features from textual medical data, such as past diagnosis reports. No matter what tool used to train them, we have registered all the machine learning models in Model Manager for governance and deployment on the Microanalytics Service REST API endpoint. This will allow batch and real-time inference, but also using the machine learning models in agentic AI workflows. Using intelligent decisioning, we have built some example agentic AI workflows that can automate processes and help timely start of patient tests and treatments. These combine protocol rules, machine learning models, and LLMs. LLMs are best advised to be deployed privately via containers for security. In our scenario, however, we were using small open source models installed locally. Our example scenario helps the patient's interaction with a healthcare provider. We first retrieve the last treatment of our patient from the medical records. Then, we call another agent via a subflow. This runs the medical text agent workflow, running various in-house natural language processing pipelines on all the previous history with the patient to extract structured medical information. Next, we branch our workflow based on the recency of the last interaction with our patient. If there are more than 2 months since the last touchpoint, a new EEG recording will be retrieved via a wearable smart EEG device from the patient to test as early as possible if the condition is deteriorating. The recorded data will be scored against the EEG machine learning model. Based on the result and the past records, the treatment protocol rule set is being run to determine the next treatment's tests. If the last touchpoint was less than 2 months ago, we collect speech from our patient. The recorded audio is being sent to an LLM for transcription and audio analysis of symptoms. Based on this audio, an Alzheimer audio score is passed back. If this risk score is high, the patient will be involved in a discussion with the practitioner, which is determined by a rule set. Otherwise, a chat completion model is called, with a prompt suitable to produce an assessment of symptoms based on the semantics of the customer speech. Finally, another LLM is called to generate a summary report. Various audit features are provided in intelligent decisioning, including the path tracking analysis, which shows where each decision ended up. For governance, SAS Lineage can display the dependencies between all datasets, explorations, model experiments, models registered, and used in decision flows. In summary, insights have been produced by analyzing EEG and other data related to dementia. Machine learning models have been built that can be used to predict signs of Alzheimer's disease. We have also created some agentic AI workflows combining ML models, LLMs, and deterministic rules. These provide useful example workflows for healthcare institutions. In terms of our next steps, we are going to continue our analysis and also engage with healthcare institutions to gather process-oriented data around dementia care.
This is just the beginning. Let's see what data could do.